K8BYP outside with a new dipole for 15 meters because there's activity on 15 with new construction methods. Cheap and easy. Instead of a feedpoint housing, which is reactive, no housing. Just soldered a couple copper loops to it, tied the wires together with a piece of paracord, soldered coax right to the wires, and covered up. Doesn't get cheaper than that. And the end supports, instead of getting fancy, I just wrapped some more copper wire around them, made a loop, soldered a loop to the wire, connected the paracord to the house. You see my pretty paint job. Cheap. Wireman RG8X coax. By the way, Wireman's specs are wrong. He states a velocity of 0.78 and a velocity for polyethylene is 0.67. So back inside. Just made a couple contacts in the CWT for the giggles. Got the funky dunky MFJ whatchamajigger to check it, because this transmitter is wideband, but it's really bad form to go out of band and transmit. So optimum at 20.66, that agreed with the transmitter. So let's dial it up. 21.1, yeah, a little bit. A watt or so reflected. And hear it in the receiver. That's the top of the ham band. Top of the ham band, 2 to 1. That's 22.5 watts forward, 2.2 reflected. Hardly enough to worry about. As we go up to the 3 to 1 SWR, where in theory it's really, really bad to operate. That's 22.46 megahertz. So the optimum is 20.6. That's almost 2 megahertz up. And the other way, optimum at 20.66. And going down the other way, of course, this is not a ham band. I can't operate here. But the point is to show how broad this antenna is. 19.2. A SWR of 3 bandwidth of 3.8 megahertz. Anybody else in ham radio doing that? Off-center feds, inverted Vs, and these wannabe pretend antenna experts? No. The antenna's 6 feet off the ground. I got to reach up. That may be 6.5. I got to reach up to grab it. But I just built it. I cut it to knowingly just a little bit long because I want to do some more tinkering to it. But I was able to calculate with a 0.951 figure the exact length. And after that, height is pretty easy. It's going to be lower than a 20-meter dipole. So I just kind of guessed and got it right. Now we're going to dispel the lies about harmonic antennas. Dipoles work on harmonics. Your ass they do. I'm going to prove it. Okay, here we go. ISWR 22.6. Watch the SWR meter. Watch it go nuts and never come back. Now what I'm finding is that here and there, the R will come to 50 and the X will come close to 80. And if we were to be fooled by this, we could think we could tune that out. And we could. We could put a simple reactance at the feed point and cancel that. But like I've explained to you in my other videos, that's an illusion. That is not tuning the antenna. Because the antenna is matched, tuned, whatever, by its length and its dimensions, not something put on the feed point. Okay, 27 megahertz on up. See the ohms coming down to a short circuit. R9, 9 ohms at 30 megahertz. Short circuit. But nowhere 31, 32, 33, 34. See, there's 50 ohms total at a real high SWR. R15 X40 is trying to load a reactance. 739, 40 megahertz. The second harmonic of 21 is 42. Okay, here's 41.4. Okay, I'll go up through 42, 43. Did you see any harmonic operation there, or did you see an SWR off the charts? You saw B. SWR is so bad it's ridiculous. 47. Short circuit at 51. So dead short at 6 meters. Nothing on 6. Just dips below 3 at almost 60 megahertz, but looky there. It'll operate at 64 megahertz. Is that a harmonic in an amateur band? I don't think so. 3 of 21 is 63, so it's not a harmonic because 3 of 21 is 63, and this is 64 and a half. But it would work there. So going up, uppity, up, 70 to 114. Extremely high SWR, 3 to 1, 3 to 1. Just kind of hanging around 3 to 1, 92 megahertz. Down about 95. That's not a harmonic. 101. 5 times 21 is 105-ish. That's not a harmonic. 107. Is that a harmonic? Yeah, it's got a mediocre match. Is that 465? 105. That's 2 megahertz away from harmonic frequency. So that's not a harmonic and not in a ham band. So who's made up this crap about dipoles being harmonic antennas? Well, somebody has, because it's BS. So there you go, antenna principles. Get the right length by the velocity at the speed of light, working out to a quarter wavelength distance, divided by 4, multiplied by 0.951. That's the exact length of the wires. No twisted wires at the feed point, no balance, no kludges, no crap. String the antenna up nice and level, flat, then play with the height. Amazing results. Almost 4 megahertz. So get to tinkering, KBYP.